Guys, Dr. Kruse here. This is a quick lesson on how to explain to me when one graph is above or greater than the other graph. So for example, I have a red graph here which I've called y2, and I have a black graph here which I've called y1. If I ask you when is y2 greater than y1, I'm asking when is the red line above the black curve? When is the red curve above the black curve? When is y2 greater than y1? All right, I could ask you, when is y1 greater than y2? Well, y1 is above y2 over here, and y1 is above y2 over here. So I need to tell you how to explain to me when that happens. Remember, anytime somebody asks you when something happens, they're talking about the x-axis numbers. So maybe after 1 hour, after 2 hours, we had an intersection. After 3 hours, 4 hours, 5 hours, whatever story you want to tell down here. But explain to me where the intersections occurred. So after 2 hours, we had an intersection. And after 5 hours, we had an intersection. And then be able to explain to me when one graph is above or below the other graph. So first of all, let's review how to explain the different sections of the graph. I have a dot on 1 and a dot on 5. All right, so I've broken this graph into 3 sections. I have all the numbers in between 1 and 5. I have all the numbers that are lower than 1. I have all the numbers that are bigger than 5. So by placing the 2 dots here, I've broken the graph into the left part, the middle part, and the right part. Now, how do I describe these 3 parts? Well, this one's pretty easy. All these numbers are less than 1. So I say any number that's less than 1. That could be 0, could be -1, could be -5, could be -1 billion. Any number that's less than 1 describes this area over here. And we're going to go ahead and include 1 as well, so it can be equal to 1 also. Over here, 6 is bigger than 5, 7 is bigger than 5, 8 is bigger than 5. All of these numbers bigger than or greater than 5 are this area over here. And we're going to go ahead and let it equal 5 as well. So 5 or bigger is the section to the right. The section in the middle, we explain that in kind of a weird way. Let me just show you an example. For example, 4, that's between the numbers 1 and 5. Let's put it in for x and see if this situation works. 1 is less than 4, yeah, that's true. And 4 is less than 5, yeah, that's true. So any of these numbers that you can put in here in between 1 and 5 describe this section right here. So it could be 2, put a 2 right there. 1 is less than 2, yep. 2 is less than 5, yeah. Any number that's between 1 and 5 counts. Could be 2.3, 3.7, 1.4. All of those billions of numbers in between are written like this. Any number between 1 and 5. So this is how you describe a section of the graph to me. You can say all the numbers smaller than this number, all the numbers bigger than this number, or you can say all the numbers in between these 2 numbers. All right, so moving to this graph, notice there's an intersection 2 steps to the right and 3 steps up, and there's an intersection 5 steps to the right and 3 steps up. So this breaks the graph into 3 parts, the part to the left, the part in between, and the part to the right. And we're just going to describe that using the x numbers. All right. If I'm asking when is y1 above y2, I would be talking about this section here, and I would say when x is any number 2 or less. I'd say when x is less than 2. If I was talking about when is y2 greater than y1, I'd be talking about this section here, and I'd say anytime that x is a number between 2 and 5. All right, we're going to use the numbers on the x-axis to describe what section of the graph we're talking about. And if over here maybe I said when is y2 less than y1, that means when is y2 below y1? Well, that's after 5. So any number after 5. So that's all the numbers greater than 5 when x is greater than or equal to 5. So here's some situations based on that graph up above. All right. When is y1 below y2? All right, let's go back and look at that. Whoops. When is y1 below y2? Here's y1, the black curve. When is it below the red curve? Just right in here. All right, in between 2 and 5. So I got to say that. When is y1 less than y2? That means less than means lower. They both kind of look like an L. All right, y1 is less than y2 from x equals 2 to x equals 5. Well, we're going to say it like this when x is between 2 and 5, and we're going to write it like this. For any number that's between 2 and 5, this situation is true. y1 is below y2. The black curve is below the red curve. What if I ask about when is y1 greater than y2? That means when is y1 above y2? Back to my picture. So y1's the black curve, y2 is the red curve. When is y1 above? Well, it's not here. y1 is below, so it's not this section. It's going to be this section out here. The black curve is above the red curve, and it's going to be this section out here. The black curve is above the red curve. So I have to describe that. Using the x numbers, I have to say, well, for any number less than 2, x is less than or equal to 2, and for any number bigger than 5, when x is greater than or equal to 5. So I have two answers for that question. Anytime x is less than 2, that's my first answer. And anytime x is more than 5, that's my second answer. I'm just going to connect them with and. Now, there are a couple of kind of sticky situations. So what if y1, this black curve, is above the red curve like all the time? See how it's always above the red curve? There's no intersection where they like switch places or whatever. So if I ask you, when is y1 below y2? y1's the black curve, y2's the red curve. When is the black curve below the red curve? Well, that's never going to happen. It's never going to be below. So there are no x's. If I had an x-axis in here with numbers on it, there's no x's that would describe this. There's no solution. If I turn it around the other way and ask you, when is y1, the black curve, greater than or above y2, the red curve? Well, it's always above the red curve. And if I had this x-axis in here with numbers on it, I'd say, well, for every one of those numbers on the x-axis, this situation is true. So since this situation is true for any number you can think of, I would say that all real numbers are solutions. All right, let's kind of look at this problem here. X squared plus 4x is less than or equal to x cubed. Now, it's handy to remember that an x squared graph kind of looks like a parabola, like a U shape, and an x cubed graph kind of looks like, I call it a roller coaster. So I'm wondering when the U shape is less than or below the roller coaster shape. And I'm just going to call this expression y1, and I'm going to call this expression y2 in my calculator. And when I graph it, I get something like this. y1 is my black curve here that's kind of U-shaped. And y2 is my x cubed shape, which is kind of roller coaster shaped. It's the red curve. So y1's the black curve, and y2 is the red curve. And we're going to have three intersections, but we're basically going to ask the same questions. We're going to ask, when is y1 lower than, see it kind of looks like an L for less than, when is y1 below y2? Well, let's go over here and look. Well, y1, that's the black curve, is below y2. Well, let's look right here. There's y1, there's y2, not there because it's above. So we hit an intersection here and they switch places. Now the black curve is below the red curve. Yeah, I'm talking about this section here. Then we hit an intersection and they switch places. The black curve is above the red curve, so not there. And they hit an intersection and they switch places, and now the red curve is above the black curve, or rather, the black curve is below the red curve. So I'm talking about two different sections here where the black curve is below the red curve. I'm talking about this section right here, from this intersection to this intersection, and I'm talking about this section right here, from that intersection kind of out to infinity. So I'm going to have two answers that I have to describe with my x numbers. Hardest part is finding the intersections. Now, if you use Zoom Standard, I mean, it'll do okay, but it won't show you all three intersections. Sometimes it'll show you one or two intersections, and then you have to kind of go look for that third intersection. So for this particular problem, you just got to kind of play with your window settings until you get a picture in your window that shows you all three intersections. All right. If you hit Zoom Standard, it's going to go 10 up, 10 down, 10 left, and 10 right. and that might show you a couple of intersections, but you're going to have to change your window settings so you can see all three intersections. I played with them and I said, well, if I go into window and set my x's from a low of -3 to a high of +3, and if I set my y's from a low of -10 to a high of +20, well, then I had a pretty good window. I had a pretty good picture of this graph that showed all three intersections. Now, once you can see all three intersections, then you just go into your calculate menu and you calculate this intersection and calculate that intersection and calculate that intersection. So we've calculated these intersections here, and I don't really care about how high or how low this intersection is. So I don't really care about the y values. What I'm looking for is when these things happened. So this intersection happened at -1.56, at 1.5 steps to the left. And this intersection happened at the origin, and this intersection happened at 2.56 steps to the right. So now I know when each intersection happened. Now I can describe these sections. Remember, I wanted this section right here, where y1 is below y2. So that's from this x to that x. That's from -1.56 to 0. That's any x in between those two numbers. So from this to this, any x in between -156 and 0, this situation is true. Now there's a second area over here on the right, from this intersection out to the right, and this intersection starts at the x 2.56. So for any number bigger than 2.56, this is true again. So when any number is bigger than or equal to 2.56, the black line is below the red line again. So there's two different sections, this section and this section, and I just have to describe where those are or when they happen using my x numbers. All right, and this is a real popular problem where we have two intersections and we're actually putting three curves on the graph. Now one curve will be some kind of growth curve, like a tree is growing as time goes by, or a puppy dog is gaining weight as time goes by. But there's going to be some kind of growth curve. And then there's going to be two levels that we need to know. For example, if this was a tree growing, maybe I want to know when the tree is 8 feet tall. So I would put a horizontal line that is 8 steps up in the air, and I would calculate when this growth curve hit 8 feet tall, and I'd pull that x value. That's an intersection. I'm going to calculate that intersection, and I'll have the x value when the tree was 8 foot tall. And maybe I want to know when the tree is 18 feet tall. So I go find 18 on the y-axis, and I put in a third equation that's 18 steps up, and I kind of follow my growth curve. Here's my tree growing up to 18 feet tall. And if I drop down to my x-axis, if I calculate that intersection, I'll know the x when this happened. So a real popular question is, when is the tree between 8 and 18 feet tall? So they'll be talking about this space in between. Well, I just need the x number for this intersection, and I need the x number for that intersection, and I'm going to say for any x in between this x and that x. Okay, so I've put in my three equations, and honestly, it doesn't matter which one you put where. Just make sure you have the growth curve in there, and make sure you have a horizontal line at 8, and make sure you have a horizontal line at 18. So the first thing that's going to appear on my screen is a horizontal line that's 8 steps up in the air. And next will appear my growth curve, and then the last thing that will appear is my horizontal line that's 18 steps up in the air. So I've set my window like I talked about, and I hit graph. There's my line that's 8 steps up. Here comes my growth curve, and there's my line that's 18 steps up. All right, so this is the tree getting taller, or the puppy gaining weight, or whatever our growth story is. And I want to know, when is this tree between 8 and 18? Well, I'm talking about this section right here. So what I need to do is calculate this intersection and figure out what that x number is, and then calculate this intersection so it tells me what x that is. And then I'm just going to answer for any x between those two x's that I found. Let's calculate an intersection. So calculate right above trace. I want to calculate an intersection. All right, now when I put the three things on the graph, I have to kind of answer their questions about the intersection. So I've got this line 8 units tall, 8 steps up. I've got my growth curve, and I've got this line that's 18 steps up. Now I want to calculate this intersection right here. So I want to make sure I put the flashing cursor on this horizontal line and then this curve. So it's asking if it's in the right place. I'm just going to scoot it over a little bit. It's saying, hey, am I on the first curve? Well, yeah, that's one of them that I wanted it on. So I'm going to say yes and hit enter. And now it's going to bounce up and down. I mean, it could bounce to that line. It could bounce to this line. It could bounce to this curve. And all I'm doing is hitting my up and down buttons. If you hit your up and down button, it just bounces back and forth from curve to curve. And you just got to tell it where you want the second curve to be. So I want that second curve to be this one right here. And I set that. I choose enter. And so let me move that cursor. So now it says, okay, we chose this line and this curve. I'm going to go calculate that intersection. And I don't want to guess, so I'm just going to hit enter again to let it think. And it goes and it finds that intersection at 1.83. We calculate the other intersection the same way. I want to calculate intersection, but this time it's saying, am I on the first curve? Well, let's see. No, it's on that horizontal line down there. I want to be up here. So I'm going to bounce it up. It says, am I on the first curve? Okay, I'll make that the first curve, and I'll make this growth curve the second curve. So enter. And now it says, am I on the second curve? I want it to be on that growth curve. So I bounce around until I land on it. I'm going to get a little closer to the intersection. There we go. Enter, enter. And there's our second x value, 2.49. All right, so I found my two x values of those intersections, and my answer is going to be the growth curve is between 8 and 18 when x is between that first x and that second x from our calculator. Here's a similar problem just to give you another look at it. Police officers can measure the length of a skid mark, on the pavement, like when you slam on the brakes and you leave a skid mark. Police officers can measure the length of that skid mark, and they can tell you how fast you were going in miles per hour. All right. So this growth curve here, this curve that's going up, 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 that is the faster you go, the longer the skid mark is. So as time goes by, as your skid mark gets longer and longer and longer, it means that you were going faster and faster and faster. That kind of makes sense, because if you're going like 30 miles an hour, your skid mark wouldn't be very long. But if you were going 50 or 70 or 80 miles an hour, your skid mark would be pretty long indeed. So another similar question would be, hey, when was this guy going between 50 and 30 miles per hour? Well, I need to know the length of the skid marks that would match 30 miles an hour and 50 miles an hour. So I'm talking about this section in between here. So I would just make my growth curve my first formula in my equation, in my calculator. And then I would set a horizontal line that's 30 feet high as y2 or y3. And then I would set a horizontal line that's 50 steps high as y2 or y3. So I usually make the growth curve my first equation that goes in the calculator. And then I set my two horizontal lines for my y2 and y3. Play with your window. Now I'm kind of cheating and telling you the window here, but the window on your problem would be basically 0 to 200 for the length of the skid mark and 0 to 70 for the speed of the car. So set your window, get you a good picture where you can see the intersections, and then we're talking about the area or the line in between here from when it was going 30 miles an hour to when it was going 50 miles an hour. If I calculate those intersections, that'll tell me this x and this x for those intersections, and I'm going to say any x that's between these two is a solution.